right when it starts to slow down, or on this side, about right there where it starts to slow down. So this is a point of inflection is where it changes its speed. You see that? You maybe want to like draw a little arrow up there. The reason that points of inflection are important on the normal graph is because the point of inflection signals to you where a standard deviation is. Because look, if I follow the line down, I should be at my standard deviation. Signals where the first standard deviation is. There's a better picture of it in the book on page 110. Then, just so we can shortcut, a normal distribution, so one of these, is represented every time by giving you the mean and the standard deviation. Remember how it told us the standard deviation so we could get this purple thing? The way they abbreviate it is that. So n means a normal curve with a mu, that's a mean, and a sigma, that's a standard deviation. So they could have abbreviated the whole story up top by just giving us that. Okay, so let's try an example. Here's a dot plot showing the number of points Michael Jordan scored in each of his 82 games in the 86-87 season. Ooh, that's old school. The mean of the distribution is 37.1. Okay, so the mean is 37.1. I'll just circle it. And the standard deviation is 9.9. What percent of his points were, ready, within 1 standard deviation, within 2 standard deviations, within 3 standard deviations? Oh, it sounds like we're going to have to make some kind of curve. Okay, can you see that there is kind of a curve going on in the graph already? The mean is 37.1. Where would that be? These look like they're scaling by 2s, 32, 34, 36, 38, so 37.1 is about right here. That would be my balancing point. Standard deviation of 9.9. Okay, so we're probably going to have to find out what is 37.1 plus 9.9. Then we're going to have to do it again and again and again. Okay, so let me get a clear screen. 37.1 plus 9.9, whoops, 0.9, 47. Okay, mark that. 47, so 42, 44, 46, 47. Then we're going to have to do it plus another 9.9, plus another 9.9, 56.9, plus another 9.9, just so I don't have to come back, 56.9. Okay, 52, 54, 56.9, so it's almost right here. And what was the last number? 66.8. Well, that's 62, 64, 66. 66.8. Now, how do we get the other side? So we do 37.1. We're back to the middle. This time minus 9.9. Minus another 9.9. I can't get the point, guys. 0.9. Minus another 9.9. Okay, label these 27.2, 22, 24, 26, 27, 17.3, 12, 14, 16, 17. And that last one, 7.4. So there's 10, there's 8, there's 6, here's about 7. Now look what we did. We basically fit a normal curve to this data. So now it asks us, how many were within 1 standard deviation of the mean? Okay, so that goes from here to here. So now you literally count up the dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 758. About 58 out of 82. Yeah, I counted from here to here. So what is 58 out of, did I say 82? 70.7. Within 2 standard deviations, so now I got to get over to here. So let's see if I can smarten this up. I had about 58 between these two. So I'm going to add on some over here. 58, 59, 60, 61, 62, 63, 64, 65, 66. There's some over here. 67, 68, 69, 70, 71, 72, 73, 74, 75, 76. And then before I go to the calculator, within 3 standard deviations would be from here to here, so they all are within there. So I know that's 100%. But what is 76 out of 82? About 92, maybe 93, or 92.7. Okay, so that's what a normal curve does. It spreads out the data, and then it just says, hey, you know what? I need 3 standard deviations on this side, and I need 3 standard deviations on this side. So it chunks all of the data into about 6 groups. 1, 2, 3, 4, 5, 6. There's actually a rule so that we don't have to count it every time, and this is the ideal rule. We just go with this idea.
Hello.
Hi. Okay, so someone came in the room, now they're going back out, so we'll keep going. The normal curve says, in general, this is how much data is in between each one. Let's see how close we came. 68, pretty close, 95, 99.7. This is in reality. This is in the ideal world. So as a ready reference, you say like this. From here to here is 68% of the data. How can I show you that? From there to there. From here, 2 standard deviations. So from here to here, I'm coming down this time, 95% of the data. And from the 3rd standard deviation out, it says 99.7, virtually all of it will fit in between here. Because remember what a density curve says is that there's 100% of the data above the x-axis. And these are density curves.